and the code will be available. And I've got two versions of the code. I've got a before and after version. So you'll get both of those to see. Most of the techniques that we're going to talk about are going to be represented in the after. I didn't do absolutely everything. I've got some limitations that I'll talk about where I'm hosting, but it has a lot of the techniques. So we'll talk quickly about performance rules. So I used to work on compilers. I'm a C# developer. So when I came to performance years ago, I was expecting to do server-side tweaking. You know, we were server-side rendered ASP.NET site. So I was expecting to have to do a lot of back-end C# sort of code things. And at the time I was looking, and Steve Soders does a lot of web performance work. And he had a very good book come out then with 14 high-level things you should do for performance. And the thing I found most interesting is he said for most websites, 80 or 90% of the time is spent waiting for page resources. So all the JavaScript, CSS, images, fonts, all of that kind of stuff. For most websites, that's where you spend your time. It's not often that you'll be actually tweaking back-end code. So I'll show you when we talk about measurements. I have run into a few sites that happen to have slow back-end code, but it's not typical, but I'll show you how you can tell. So from just general rules about things you want to do for performance, you want to make fewer HTTP requests. I put that in italics because that was true in the HTTP 1.1 days. HTTP 2, that's less of a penalty, and I'll get into that later. So I still think you need to focus on only using things you actually want. But if you do want it all, a lot of the techniques I used to teach for optimizing in HTTP 1.1, you probably don't want to do in HTTP 2. The other two apply all the time. You want to send as little as possible, and you also want to send it as infrequently as possible. So when I get into techniques later, I'll map them back to what they're trying to solve. I do use Fiddler a lot in my talks. So if you're familiar with Fiddler, it's a tracing tool built specifically for HTTP and HTTPS. So it was created by Eric Lawrence. He worked at Microsoft on the clip art team, and people would call in and say, I paid for clip art, I can't download it. And he noticed the support people really had a hard time troubleshooting. So back then it was a network monitor, which is a Wireshark type of tool. That was really all you could use for tracing. And it worked, but it was at a packet level. You had to kind of reconstruct everything. It wasn't very convenient, and it captured a lot of traffic besides HTTP. So Eric didn't know .NET, he didn't know C#, he didn't know HTTP, but he decided to go learn all that stuff and write Fiddler, which I think is cool. It was acquired by Telerik in 2012. So I gave you a link there. There's two different versions now. The first one is Fiddler Classic, which runs just on Windows. That's what I'm going to use today because some of the techniques I use only work there. They also have Fiddler Everywhere, which is cross-platform. So they've rewritten it to have a more modern user interface and to work on Macs and Linux. So pick the one that's appropriate for you. Every release, Fiddler Everywhere is adding features that were in Fiddler Classic, and now it's also adding things that Fiddler Classic couldn't do. So you just need to decide which one's right for you. So I'm going to show that first because I want to show, I'm going to actually open up a browser quick. So I've got a fictional travel website. And get this open here. That's what I'm going to use for the before and after. So I'm going to open up Fiddler, make sure that's running. So again, Fiddler is just watching all of the traffic between the browser and the server. So I get to see all of the requests that are made. So I'm going to go back and request that first page. And I'm going to hit Control F5 here just to make sure that in case anything was cached. Now we'll take a look at what Fiddler shows us. So I'm going to focus on right here. This is the second request that was made. So one thing I like to do, I come in here, I can see I'm getting some other background calls, so I'm going to take those out. I'm just going to go through the statistics. So on the right, you can see there were about 12 requests to get that page, and it was almost 3 meg. Typical web pages today, that's a pretty typical size, but most pages are somewhere in the order of 100 requests or so. So we're going to walk through how we can use this, but I just want to show you quickly that This is the first thing I like to do. I like to get just an idea, and there's some clues I'll start to pick up from some of the stuff in here that we'll go through during the talk. But just for comparison, I'm going to pull up the after. And what you should see, it should visually look the same. But if I were to go take a look at some of those requests, that one, now we can see it's still 12 requests, but we're down to 128K. So the entire size now of that page, if we go back and look at some of the images and JavaScript files and CSS, 128K is less than almost any of those single requests. So that's what we're going to focus on, is all of those techniques that allow us to do that, make it a lot faster, and yet make it look the same from a customer's perspective. We're not giving up anything. It's important to know metrics. So there are a lot of different metrics that you can use for web performance. The first one I put in italics, it's useful for IT, so it's called first byte. So basically that's how long it took the browser to make a request to the server and get the first byte of response. So I do look at that. If that is long, so if that's a second or more, then you really probably do have a back-end problem, and you should focus on the code that's actually doing database requests, whatever, to create the HTML. Typically, I'm going to focus more on the customer facing metrics. So one that I used years ago, we still use it, is called speed index. And so speed index is supposed to be a measurement of how many milliseconds it takes to paint the above the fold content. So if you're familiar with that term, above the fold is just what's currently visible in your viewport. So it's a nice quick measurement that tells me about how long before you could see most of the primary content. There's other ones, time to interactive. Years ago, we used onload. I still look at fully loaded, which just means all of the resources on the page are done downloading. But lately, Google decided that they wanted to have some more user-focused metrics. So they created what's called Core Web Vitals. So Core Web Vitals, there's different aspects of performance, and they wanted to make sure that they had a measurement for each of the important ones. So the first one is largest contentful paint. So the idea with that one is just typically pages will have a hero image or the main thing they're trying to show. That's what largest contentful paint is. First input delay is the page is visible. I'm sure you've done this yourself. You've gone to a page, you start to click on things, but it's not actually interacting yet. There's stuff going on the main thread or JavaScript running that's stopping it from being interactive. So that first input delay measures how soon after you can see the page can you actually interact with it. And the last one, cumulative layout shift. I'm sure this has happened to you as well. You go to a web page, it starts to paint. You're about to click on what you want to click on, and suddenly everything shifts, right? Either ads come in or images come in. It's really irritating from a user's perspective. Cumulative layout shift is a measurement that tells you how much it's moving things while things are being rendered. Google is using that for search engine ranking, and I was surprised a lot of the business people I work with started to hear about this because it was ranking and it was SEO. They got familiar with this like they never did for other metrics. So I'm starting to put more focus on Core Web Vitals as a good 3 measurements that kind of tie into all the different parts of experience. Once you pick your metrics, it's very important that you measure. So you want to, typically when I'm going to do a performance thing, I want to measure before I do it. I want to do the change, measure afterwards, because I want to make sure sometimes it will work out. Some of the techniques I'll teach you are just, they flat out make sense for everyone. I've never seen it where it isn't useful, but there are some where there are trade-offs that you may not want to make. So it's important that you measure and make sure what you're trying to do is actually getting the experience that you want. So there's 2 different ways to do that. Webpagetest.org is a free tool, and they've got machines all around the world that you can test from. So I like to use that. We're going to take a look at that in here. And then I also use Fiddler a lot. So as soon as I go to first time I look at someone's site, I'll go into Fiddler. I know the rules I'm looking for. So I'll start to pluck through quickly looking for large files or other things that we'll talk about throughout the talk. So those are the 2 that I use. It's also important to understand synthetic monitoring. So we've paid a service for many years that monitors our website, and it's called synthetic because they have a certain number of hosts. I think we've got either 5 or 10 locations throughout the United States that hit my website, the homepage, products, categories. They're measuring, and the reason that they call it lab data or synthetic is it's not a real customer, right? It's an agent. I like it because I know every week it's going to be the same computer, same ISP. So as I make improvements, that's one good thing to look at is consistent clients. How are they behaving now versus before? It's also important, however, to look at real user monitoring. So we do this as well, and they call this field data. And there are 2 standards I listed on there that came out years ago for the browsers that enable RUM vendors to track client side, basically everything that's happening on your site. So I like it because the synthetic, I have to record walking through my site and which pages I want to use. Real user monitoring, I just drop JavaScript onto the page. It's using all of these standards below. It's capturing all of the timing on the client and sending it back to the RUM server. And then I can, excuse me, go query and I can see all my actual customers. So I get to see people on phones, tablets, slow connections, fast connections. It just gives me a breadth of testing that I don't get from synthetic. So it's important to use both. So let me pop web page test here. So like I said, this is a free tool. They have recently been purchased, and so they've been making a lot of improvements lately. So every time I come here, it looks a little different, and they've got some new features. But the primary thing I want to do is I can just come in here and type in the website that I want to test. And then they have simple config, so I can just choose I want to see it on a desktop from Virginia, or I can open up and look at very specific, like what type of connection is it, what's the browser. So I would kick this off. It takes a little bit to run, so I'm just going to use my pre-canned. So I hosted both the before and the after out in Azure, and so I'm going to look at these 2 reports and just walk through what you'll see. And I accidentally pulled up the wrong one there. So again, the tool hit this page, did the recording. It's going to give me a quick summary. So across the top are some of the major metrics that we'll look at. So we can see that it ran it 3 times, and it shows the first run number 2 was the median. So I can start to look at the metrics like 3.08 seconds. That's not too bad. So about 1/3 of the second to get the first byte. So not a lot of server side time, which is good. If we look at speed index, again, it was at about 1.7 seconds. Most of the content got painted. It was 2.647 seconds to get the largest contentful paint. This used to be about 6 seconds. Over the last year or so, the browsers have been doing a lot of tweaking, so it just got better because the browsers got better. You can see I have cumulative layout shift, so I think the top value here is 1. So I've got quite a bit of shifting going on while it's rendering. And then if I slide over here, they also give me a couple more metrics, total bytes, things like that. It's cool because they do screenshots, so I can actually look across the timeline and see how it's being painted, which is very helpful. And then I can also see, I find it helpful to look at videos as well. So I'm going to show you the video for this just so we see how this one's painting. I'll actually get the second one because that's the one it took. I like to use this with business people because if I tell them, you know, it's 25% slower or whatever, that doesn't always settle in as much as a video does. I think showing them the visual of how the page painted is a lot more impactful. So you can see the stuff is shifting, filling in about 3 seconds or so. It looks like it's pretty well done. So I'm going to go back here. The other thing we're going to focus on in Webpagetest is the waterfall diagram. So if you've seen these before, this is the actual requests that were made for the page. So it's very similar to Fiddler, but it does give me some nice graphical things. So I can see here's the main page, and it breaks it into DNS time, connection time. It shows me I'm using 2 JavaScript files, and it's indicating here that these are render blocking. So we'll talk about JavaScript and some of the options, but JavaScript by itself stops the browser from rendering. So as soon as it hits a normal script tag, it's going to wait to download that file and execute it before it will do anything else. So it's telling me that these two JavaScripts are making it wait before it's going to do any painting on the screen. Then we get CSS, and then we can see some images. And I like the visual here because I can see those images are taking seconds to download and display. So here we're at about 1.4 seconds, and it took out to about 5.2 before it was done. A lot of more stuff about CPU, bandwidth, threads. I usually don't spend a lot of time on that, but it's there. I do look at connection views. So the other thing to note here is for performance, and this is using HTTP 1.1, the browser will open up multiple connections to each host. So even though all of these files pull from the same host, the client actually had to open up 6 separate connections so that it can do things in parallel, because each connection in HTTP 1.1 only gets one request at a time. So this was the way the spec originally said 2. You should do 2 connections. It didn't take the browser vendors too long to realize if they cheated slightly and did more, they'd have stuff finish faster. And most of them have all settled on just doing 6 connections. So if I go look at, we'll pull up the after just to show you the difference. The scores are going to be better. The first byte is close to the same thing. They're both static files. So start render, we can see the speed index is down from 2.7 about to just about a second. But the other thing they do, these are the core web vitals. You can see they used color. So they're telling me now, compared to other sites and best practices, they're all now green. So I've got it where the largest contentful paint's at about a second. There's no shift, and there's no time to for the interactive stuff. So you can see the paint here. It starts out, it's waiting for resources, and then bam, the whole page is done. Again, I'll go down here and watch the video just to see visually how much better it paints. But you can see, and then it's all done in one shot. There's no shifting. So those are the kind of things we'll see using the techniques we talk about will give you that kind of a result. And then I'm just going to pop down here and look at connections just to mention if I go into one of the waterfalls. So the waterfall again here, I can see that, to be aware, it looks like it's just as long, but that's the graph, right? The whole time for this is only out to 1.1 seconds. So I can see that I'm doing DNS, I'm doing connection, I'm using HTTPS. You can see that these things are all downloading a lot more in parallel. I've still got some blocking going on now because of CSS. I was able to push the JavaScript off, but CSS is also blocking. So CSS, while it gets the file, it won't paint. So it's a blocking of my rendering. So it's nice they tell me that. And if I look at the connection view, you'll see what's interesting. I am using HTTP 2 for this one, so I only need one connection, and we'll get into that later. But that's basics of how you can measure with free tools. But again, I save these off. So if you noticed, I just have saved URLs. I have a journal for performance, which I also recommend. I'll just take snapshots of this and say on this date, here were all the measurements. I'll keep this URL to Webpagetest. They keep the results out there for quite a while. So I can go back and look at my waterfall diagrams, because it does happen, a year later, somebody will say, why are we doing caching, or why are we doing compression? And I like to show them, before we did it, it was like this. After we did it, it looked like this. So it's a little better story. Once you know your metrics and you've got your measuring set up, your next question is, are you good enough? Are you happy with where you are? So what's useful to know is, does your website performance impact your goals? So both Amazon and Walmart intentionally slowed their website by 100 milliseconds. So they did an A/B test. They'd split I don't know if they did 50% or how they did it, but let's say 50%. They split their customers. They intentionally slowed down one group by 100 milliseconds so they could see what that did to sales. And interestingly, both of them lost 1% of their sales. So if you think about that, 1/10 of a second means 1% of your sales. So from a performance perspective, it pays for them to make improvements because it hits their bottom line. They can actually relate it back to increase sales. I would love to do that for my website. I've not been able to convince the business to let me intentionally slow some customers, but it would make my discussions about performance so much easier, because I have a designer who comes and says, why don't you put a new font on the site? And I say, okay, it's going to slow. I can measure. Putting that new font on is going to cost us 100 milliseconds, whatever the measurement is. So I say, from a perspective, I'd rather you not. But I don't have any hard numbers. If I could run this for a day and find out how sensitive are my customers to performance, then every discussion going forward would be a simple ROI. You want the font? How much do you think the new font's going to bring in income? And I can tell you, I know you're going to lose. If we're like Amazon, we're an e-commerce site. If we're like Amazon, if it's 100 milliseconds, we're probably losing 1% of our sales by using that font. Do you really think the font is going to bring in that kind of money? So it would make my discussions a lot easier. You can compare yourself to competitors. So SpeedCurve is a rum vendor, and they put out a free service here we can look at. And I like to use this because I think it is important for you to compare yourself against others. So unfortunately, in the performance world, years ago, Jupyter Research did some research and said, what do customers expect for page performance? And the number was 2 seconds. They never said what that was, like fully done or just the image done. So a lot of people have it stuck in their head that pages have to be done in 2 seconds. So I like to come out here. So this is actual data from a rum vendor, and I'm in the retail sector. So if I say I'm retail and I'm on a slow connection, I want to see what the big sites do, right? How is Target, Walmart, Amazon? They're actually pretty slow, right? If you've got slow connections, everybody's going to take a while. So if my site happens to take 4 seconds and they said, shouldn't you be 2 seconds? I can say, well, that would be great, right? But no one else is. You know, I can't fix physics. Speed of light's the speed of light, right? So if they have a slow connection, it's going to make everybody slow. So it just makes people feel slightly better about where you sit in comparison to some of your competitors. So that's useful to look at. Other one is if you use Chrome, and there's a couple situations they do telemetry, they're actually doing RUM from Chrome and reporting back to Google. So even without paying a RUM vendor, you can come out to this URL here, this tiny URL. And if you come out here, you can actually punch in your URL, and as long as you get enough hits, I'm not going to do it now because it's going to take a little while. I can punch in my domain here. And if I were to run this, they're going to actually give me a report based off actual Chrome users. So that's one of the negatives, right? It's only Chrome, but Chrome is on mobile and desktop and such. So it'll give me some quick data about my site. It'll tell me what my typical home page is. That's the other thing. It's just the home page. Here's your home page. Here's your current speed and how you compare to others. So I like to use this internally to also measure our site and say this is what Google and Chrome users see. And then again, avoid unnecessary optimizations. In other words, you could spend the rest of your life making little mini tweaks on your site that really don't impact your bottom line. So you just don't do things just for fun, right? From a performance perspective, make sure you're doing things that are making an actual difference for your customers. And that comes back to measurement and everything else. Okay, so we're kind of through the background. So now I'm going to start getting to techniques. So in here, I've kind of ranked them with the, I would say the most obvious, the most impactful things first. Again, that virtually everybody should do. Again, test this out for yourself. I can't show you, we all have different environments, right? So the other thing I should have said about the talk is it doesn't matter what you're using. I'm an ASP.NET developer, you're using React, somebody else is using something else. These techniques apply to any type of website. So again, I'm not going to show you how to actually light this up because we all use different web servers and stuff. I want you to understand the conceptual about what it is, and then you can figure out on your platform how you turn that on. So the first one is HTTP compression. So we were hosting in rural Minnesota for our e-commerce site. years ago, and we could not get enough bandwidth into our building. So our site was growing and we couldn't get enough bandwidth. So I went looking and HTTP compression was there. So what compression does is the browser will send up this server or this header, except encoding, telling the server that I understand how to do compression. So if you're familiar with PKZip and those kind of tools, they just make the content smaller, so it's going to download a lot faster. There's different algorithms to use. gzip is probably the most popular today. Deflate, Brotli is a relatively new one. It compresses better, but it uses a lot more CPU and it's slower, and it's not currently supported by IIS, which is why I don't use it yet. But you can look into those. We turned on compression, and the next day we had cut our bandwidth usage in half, which is a big deal, right? I didn't have to pay for as much bandwidth. So if you can imagine your bandwidth bill being cut in half, that's a good thing. It gave us breathing room. But I also noticed that the synthetic measurements we had in place were 25% faster. So those agents that were checking, because we didn't have RUM back then, the agents that were checking our site, they were 25% faster. And the great thing is it's just a simple web server setting. So I just go in and say, I'm going to show you how to check. Most servers today are going to compress your static content. So your JavaScript, CSS, those kinds of things compress really well. Images are already compressed, so we're not going to do those. But I also use it for my ASP.NET pages. So even though only one person's going to see the page, I will still run compression on it because that saves enough in the download that it's worth it. And again, measure for yourself. On the JavaScript and stuff, it only has to compress it once and then it saves it cached. So let's go take a look at what this would look like in Fiddler. This is how you can tell if you're doing it or not. So I'm going to pull up the after version of the site. I got to hit Control F5. So if I go back into Fiddler, if I click on the CSS and I go over to the inspectors, it's going to have this little bar here that says the response is encoded, and you can see it's using gzip, and it's 37K basically. If I wanted to, I could say, well, what would it have been if I didn't use compression? It would have been 160K. So that's a huge saving. I mean, that's a fifth the size it would have been without using compression. So that's one place I get a very easy win, is the browsers. All the browsers supported today, all the modern browsers. So it's just a quick way to greatly reduce how much you actually have to download for those text-based sorts of files. The only knock on this in the past was it used a small, single-digit CPU usage. Again, you need to measure for yourself. I haven't seen anybody who's come back and said, I'll word it differently. If you're within 2% of CPU usage where where your server dies, you have other problems, right? You should have enough overhead to do this, and it's going to save you on your downloads. So it's one of the first things you should look at. Next one is content expiration. So the idea with this is someone comes and visits my site today. They're going to get my HTML. They're going to download all my JavaScript, CSS, images, web fonts, all that stuff. It's going to be stored in their browser cache. Then they close the browser. They come back tomorrow. I'm running an ASP.NET page. Something might have changed on the server. So I want them to re-request the ASP.NET page because something might be different, right? I might have a different sale. I might have new products. But ideally, if nothing else changed, none of my JavaScript or images or any of that, I don't want them to download it again. It's sitting in their browser cache. It's never going to be faster for them than to pull it right off their own machine, out of their own cache. It doesn't use any of my bandwidth, doesn't hit any of my servers. It's going to be a lot faster for them. So that's my goal. So by default, if you don't specifically set how long content is considered fresh, you're leaving it up to the browser to decide. So browsers use heuristics where they look at, well, how long ago did it change? And a lot of times they'll call the server and they'll send this header. They'll say, I've got this sitting in my cache, but I'm not sure if you changed it. So they'll talk to the server and the server will say 304, it didn't change, or they'll download it again. So the bad news is for small files, it's just as expensive just to ask if it's been modified. So that's what I'm going to try to avoid. So I'm going to specifically choose folder by folder how long I consider that stuff to be fresh. So if I go back to the after version, I'm going to slide this over a little bit. For CSS, so this is in seconds. So max age, this is a year. So I cache all my CSS, JavaScript for a year. The images, I chose 30 days as a good trade-off. So by default, if that browser comes back and nothing has changed, it's going to pull all of those off my browser cache and not go to my server. So when I tell people that, some people are like, well, what if you have to change that, right? Let's take logo, for instance. I have logo.svg, right? It's just the main logo on my page. If I want to change it and I put out a new logo tomorrow, I just need to change the URL. So there's multiple ways to do that. You can put a version number in it. So I could call it logo2.svg. You can do question mark like parameters and just add. So what I do for real life, all the images we have, when I serve an image from our CDN, I slap on it looks like a hash value. It's not actually a hash, but a value that represents it's actually the tick count for when that file was last modified. So it's not hours, minutes, seconds. There's a tick count you can use in .NET. I put question mark that tick count. So if I change that image, because if I change the URL, the browser's going to look and say, I don't have that in my cache. It'll go back to the servers. I get the best of all worlds. If things don't change, it'll pull it off your browser cache. Otherwise, in the case that it does change, I can force everybody to skip their cache and come back and get the real file. So that's content expiration. And for me in IIS, I just break it up by folder. So I just go to my CSS folder and say, I want that to be a year. I want my image folder to be 30 days. You just set that specific what you want right there. And then the browser will do that for you. Okay. Next one is a content delivery network. So I like how things work. Literally, if you read this story or some of the background, two developers, I think they were in a bar. It's not a joke, it's an actual story. And they started getting into an argument and they said, what matters more? Is it bandwidth or latency? So if you're familiar with every time you ever go to an ISP or somebody, they're always talking about we're, a gigabit or we're 100 megabits per second. They always talk about bandwidth. Nobody talks about latency. So bandwidth is how much you can send down the pipe at one time. Latency is how long it takes for you to do a round trip. So it turns out if you follow that story, they said, well, let's set up a test, right? So they did, we're going to make the latency less or we're going to add more bandwidth. And it turns out for most websites, adding bandwidth helps until you're at about 5 megabits per second, and then it really doesn't matter. I mean, it obviously does for Netflix, right, or streaming services, but regular websites, bandwidth really doesn't help you much, and you can follow and read the details in there. But latency does. If you can cut the latency in half, it's a linear line. Your site's going to be faster if you can have less latency. You can't change the speed of light, right? It takes a certain amount of time to get from here to there. So the idea with a content delivery network is they have servers that, for me, are set up all around the United States. So when you come and visit my site, you'll come back to, we host in Minnesota. It's the ASP.NET runs in Minnesota off my server, but I reference all the images and the JavaScript and CSS to come off of a CDN. So what the CDN does is, let's say you're all in St. Louis and first person comes to my site, comes to the server, it says, hey, we happen to, I don't know if it's true or not, but let's say we happen to have one of those CDN nodes in St. Louis. The first person would go to that CDN and say, I need logo.svg. CDN might say, I don't have it yet. It goes and gets it from me. It brings it locally, and then it caches it locally in that server. So the rest of you, when you come and visit the site, you're now pulling the images and stuff off of that. So instead of being all the way to Minnesota, or if you're a global site, from Australia to US, you're going to be hosting on a server that's a lot closer to your customers. That's the only way you can fix latency. You can't make it be faster. You want to avoid it. And so that's what a CDN does. So again, for me, all around the US, there's ones that are global. They offload work from your server, so I have a lot less bandwidth usage because all of that stuff, not only is it faster because it's closer to you, it's not using up any of my bandwidth and it's not using up any of my server resources to serve it. Typically used for static files. Like I said, I've been doing images, CSS, JavaScript. Fonts I use, I put it in italics because there's some deep HTTP2 connection stuff around fonts and things. I still choose to host them there. I also choose to host as much as I possibly can on my own CDN. So even though I could pull, we use Google Fonts, I could point to Google servers, but that's another DNS lookup and everything. I don't want to do that. Once you resolve my CDN name, I want all of my resources to come from there, so I don't have to go out elsewhere on the internet as much as possible. So let's look at what that would look like in code. So here would be an example. So here I am pulling from, like I'm pulling jQuery from some public servers for this sample, just so you can run it easy. But this is the way you normally in the past would have had JPEG files. So I've got this JPEG file. If I do a CDN instead, the CDN provider will give me a new DNS name like cdn.example.com. And the trick is when it resolves the IP address with DNS, it gives you the one that's closest to you. That's how it figures out to direct you to that server in St. Louis. And then I just reference it using that full path, and that's all I need to do. And again, the rest of it stays up to date. And the CDN honors all my cache expirations, compression, and all of that kind of stuff. The cool thing is there's a ton of CDN vendors and they're eager for your business. So every year it's a better deal, basically. It's a lot cheaper and more effective for us to use them, not only for the speed, but offloading all the bandwidth. So that is content delivery networks. Next, we'll talk about bundling and minification. So the idea here is I want that rule that we want to send less to the client. So the idea, if you've seen these before, we'll look at a before and after here. So let me pull up my before and after view. So I've got my performance before. I'll just show you what a minified file difference is. So performance before, I've got bootstrap.js is about 134K and jQuery is about 281K. You can do minified versions of those. And you can see now that jQuery is only 71 and Bootstrap is about 59. So if we open this up, we'll just open up with Notepad here just to show you. You've probably seen minified files before, but they basically strip out all the comments. Usually this one has a header they wanted for legal reasons, but this is minified. So what you do, we did this on our site. At build time, we will take all of our CSS, JavaScript, we're using grunt tasks, you can use gulp, webpack, whatever you want to use, but it will minify the files. So it takes the original source, runs it through those tools, minifies, takes out all that stuff. That's what we want to serve in production because our customers don't care to look at all of our JavaScript and CSS. So we did that. In the HTTP 1.1 days, it was expensive to have multiple requests. I showed you those 6 connections. If I had 50 files, you could only do 6 at a time. So back then, the idea was we took all of our JavaScript and bundled all of the separate JavaScript files into a single file or a couple files. And same with CSS. We took all of our CSS and put it into one sheet because it didn't have to use multiple connections. So by doing this, I used all free tools as part of our build process. Took 10 hours or so to set up or whatever it was, but our homepage was 46% faster. So think about that, almost cut it in half just by doing bundling and minification. The reason I put bundling in italics is in HTTP 2, there's not as big a penalty to have multiple requests. So you may not need to do bundling. And we'll get back to that later. But minification always makes sense, even with compression, because the compression, they've done a lot of research and studies, the compression is even better when stuff is minified. You can minify HTML. I don't. for two reasons. I've seen it where it could impact how things get rendered, and also I have not found a good tool for ASP.NET that would do it at runtime. So I've just never explored doing it for HTML, but I've done it for CSS and JavaScript for many years, and it's worked out well for us. Next, we'll talk about images. There's a lot of things around images. I think the latest HTTP archive and Web Almanac, the average footprint for a page, like 2/3 of it is usually images. So one of the things you can do is avoid images if possible. So I've been doing web development forever. In the past, if you wanted to do a gradient where you went from like red to white, you couldn't do that. There was no way to do that on the web. So you'd have to actually create an image that had the gradient. So we would use images for gradients. I was doing development before web fonts. So designers would want a certain font that wouldn't be available on all of the devices. So they would actually put the text with the font they want in an image. So I'm serving all of these images because we lack the ability to do it otherwise. Now CSS3 has gradients. We have web fonts. If you can do it not using images, it's generally going to be faster and smaller. So just look into whether CSS could do those things. The other thing is use the proper types. So there's a lot of arguments for people saying you should use a certain type for serving your images. If you're serving things like logos, today the best choice is SVG. The reason being SVG scalable vector graphics, they're resolution independent. So when I create our website, we use responsive design. So I have to look good on a phone, tablet, and desktop, and big TVs, any kind of device might come to my site. If I put the image in an SVG, it's mathematical, so it will scale. So I only need one single logo.svg, and it's going to look perfect regardless of what resolution I'm on. That's the advantage of SVG. So if you're doing logo sorts of things or line art, you want to use an SVG. If you're doing photos, you want to use a JPEG. There are other choices. There's WebP, AVIF. The typical one people were doing instead of JPEGs were PNGs. And usually I'll get in discussions, let's call it, with people that are saying, well, why don't you do it with PNGs? They can do photos. Well, they can. So I've got two different images here. I'll just show them to you quick. So I went to Australia. You can actually walk up the Sydney Harbour Bridge, which is kind of cool. So here's some people going up the bridge. So this is the JPEG version. Here's the PNG version. So visually, if I were to stack these two next to each other, the quality is relatively the same, pretty close. But if I were to look at the details here, so I always say, if you're not sure, rather than argue, prove it to me. So I did it. I did it as a PNG, and I did it as a JPEG. My JPEG, I could get to 58K. The PNG is 516K. So it's 10 times larger to do the PNG. And the reason, I'll show you why that matters for JPEGs, so we'll get into that. Some of these are new formats like AVIF or WebP. Those are there. So if you haven't been out here before, there's a site called caniuse.com. It looks like Can I Sue, and you might not win. But so Can I Use, you can come out and do HTML, CSS, TLS, all these different things, and you want to know what the client support is. So if I come out here today, AVIF makes smaller photos, but it also doesn't have great support. I happen to have a lot of customers that are using iOS, and it's not supported on Safari, which would mean that I would have to have two versions. I'd have to have the AVIF and the JPEG fallback or something else. And again, I could get some better perf, but it's work. It's enough work just to get everybody to get the right photos in general. Getting multiple versions of photo and having to use picture tag and with polyfills and everything just wasn't worth it for me. But be aware there are some other formats, and maybe that works for you. But the important thing is don't use PNG for that. Use JPEG at least. Next thing is responsive images. So we did responsive early, and there was not a way to do images. It was just the image source tag. Well, the problem, if you think about it, I'm making a site to work on a small device like a phone and also on a desktop with really good high pixel density displays. So if I can only point to a single image, I'm going to use the really good desktop image because I want it to look good there. Well, the problem is I'm making mobile people download really big images that they then just have to shrink down. So responsive really got a bad rap when it first started because images were not well supported. So people would say responsive sites were slow, especially on phones. So the community actually came together and said, we need a solution. And they came up with source set and picture. So I'm going to show you what that looks like. So the idea here, if I pull up one of these images down below, we'll do that bridge walk again. Instead of having it be image source, I use source set. Ignore this data dash for a minute. We'll come back to that. But I can create various width images. So I just say, hey, I've got same image at various sizes because they might be used on different devices. I tell the browser, here are the sizes, the widths, you pick the right one. You know the pixel density of the device, you know how big it's supposed to paint, choose the right one, which honestly was really hard for me when I first started using it because I'm kind of a control freak. I thought I kind of want to force what's going to get chosen. But we've been doing this forever and it works really well. And again, why you do this, if we go back and look at some of the sizes, doesn't look like it. Open that again. So if we go back and look at how the difference in sizes for that. Let's go look at performance after. We'll look at the images again. So if I look at the details for bridge walk, the 128th width is only 2K. The really good one, 2048, is 187K. That's nearly 100 times larger. So if you think in the old days before we could do this, I would always have to serve this one. And so I'm able to cut that from 187K down to 2 just by using source set and the responsive techniques. Picture is another choice. It gives you the ability to do polyfills. So you can say, use the AVIF if it's supported, use JPEG otherwise. Pictures also if you do what's called art direction, which it's not the exact same crop. Like as you get smaller, you want to crop it differently, you'd use picture. But the point is, use one of these. I mean, pick the right, because you want to get the right image for the right situation. And that's what responsive images let you do. There's also a new thing called client hints. Pretty new. There's some parts I don't love about it, but the browser will send to the server and say, here is my pixel density. It'll tell me enough info that I could potentially on the server look at that and choose the right image for you. Again, I'm not using it yet. I think it's still a little early. It's not fully supported. So I'm not going to show it here, but just kind of keep an eye on that. So those are some of the image things. So again, why JPEG? Well, the reason I picked JPEG and similar ones and not PNG is because I can do compression. I can trade off size versus quality. So every time I say that to business people and web designers, their turtlenecks just tighten when they hear that, like, you're giving up quality, you can't do that. You can often cut the size of images by 50% or more without impacting their quality. It's easy to do. So again, I'll get into, we'll call them discussions with people about this. I say, I tell you what, I'm going to give you a page that looks like this. I put the same image out here, compressed in different ways. And I literally said to my designer, if you can pick the one that you think is the original and you pick it right, I will use yours. If you look at here and can't tell, then we're going to use the one that I've cut to be a lot smaller. So I throw in a couple of freebies that look really crappy because they're too compressed. If you look at these are all pretty similar, even stacked side by side. It would be hard for somebody to tell the differences. So it turns out this is the original. That's 172K. This one here I compressed, it's only 32K. So again, I've cut it about a fifth of what it used to be without visual degradations. So any of your tools, Adobe Photoshop, I use PaintShop Pro, a reasonable editing tool. You can go in and when you save the JPEG, they often have where they'll pull up the two images and there's just a slider. So you can just play with the slider until it gets to the point where you can start to see the quality go away and then you back off a little bit. We actually do Adobe Photoshop batches. So we get all of our product pictures, we crop them, we put the original out. As we run batches, it'll spit out the 6 or 7 different sizes we want. And for that, we just chose a compression level that we knew would be pretty decent across all the images, so we don't have to do manual work. So we just kick off that batch. It took our single set of images, it created all the responsive sizes compressed the way that we want them compressed. So that's kind of cool. You can also do progressive JPEGs. So I'm going to show you, these are becoming popular again. You have not heard of this before. So I'm going to go into Fiddler and I'm going to make it intentionally slow. I'm going to make it act like a modem. I want you to watch the paint. So if I pull this up, I'm going to have 2 images here, left and right. So the left one looks like it's done. And the right one makes the perception that your site is super slow. So what's the difference? So on the right is what 90+% of JPEGs are on the internet. They're called baseline. And so they're just a normal JPEG, but they paint line by line. On the left is what's called progressive. So if I do it again, I'll do Control F5. It brings the whole thing in and then makes the quality better. So it paints just kind of a blurry version and then makes it improve. From a perception standpoint, if someone's on a slow connection with a bunch of images like this, the right one makes it feel like your site's just crawling, whereas the left one pops a lot faster. So now that people are doing a lot more mobile and have slower connections, people are going back to progressive JPEGs. The tools you use will be similar. So I mean, Photoshop, everything you use today will work, but when you save it, there's actually an option to say, I want it to be saved as progressive. They turn out to be about the same size, so there's not a size penalty. The research I've looked at, the only real penalty is they say progressive uses more CPU on mobile devices. So if you're mobile device specific, you do want to test and make sure that the type of devices you support, it's not taxing their CPU. But in general, a lot of major websites are starting to go back to progressive for that. The other thing I do is I use Jpeg Trans. So I'll show you this one. I'm going to turn on another feature. I'm going to put our performance back so we're not super slow. There's an extension for Fiddler Classic called Show Image Bloat. If I go back here and pull up the site again, I'm going to hit Control F5. So on the left side, images, so you take a picture with your camera or your phone, it embeds metadata into the picture, like what was your shutter speed, it might have your lat long, all those sorts of things about that don't do anything for the visual properties. They're just extra data stored along with the image. I want to take that out. So if you look, it uses bricks to represent that about 15% of the size of this image is because of its metadata. So I use a tool called Jpeg Trans, a command line tool, and we also run that in our batch. So we strip out all of our metadata before we host it. So I'm cutting out 15% of the size in the download that's not needed, because my customer doesn't care what the shutter speed was, right? So it's just something I should remove. To be aware with that is copyrights are stored in there. So if you license images, make sure that they allow you to remove the metadata, because they might be sensitive because of the copyright. But those are some simple things to do with JPEGs. And you could see when I showed you the before and after at the beginning, the images were 300K-ish each. And I was able to get them to where the whole page now was like 128. So I can get images to be much smaller. And visually, again, you don't notice any quality degradation. But I got a good performance boost out of that. The other thing we do is image lazy loading. So the idea with this is we're a food site. Years ago, we used to have what search engines would. You'd come to our ice cream category, you'd see the first 10, and then you'd have to kind of hit page 2, page 3, page 4. Our designer came and said, I'd really love it to be one long page. It's better for SEO. It's better experience, he thought. And so I said, that's great, but now I'm downloading 90 images, no matter what. Everybody who comes to the ice cream category, or whatever the number was, are going to get that many images, whether they actually look at the page or not. So the idea was I wanted to only download the images that are above the fold, and then I want everything down below to not load until you start to scroll. So the way you do that, I still use this today in production. It's a really well supported, it's called Lazy Sizes. and you basically will download a JavaScript file and change your URLs. So if I go back to the code, that's what this was. Normally this would be source set. I put data dash source set in front of it. Data dash lets me set attributes that browsers ignore. So the browsers are going to see this image tag and there's no source set. They're not going to do anything. I tacked this class on called lazy load. So this is an image that I know is below the fold. So if I go back to our original page, you know, these images are here. I'm talking about these down here. These ones are certainly below the fold. So I put this lazy load on. I change it from source set to data dash source set, and then I include lazy sizes right here. And what that does now is, again, the browser ignores it. As soon as I start to scroll, that JavaScript is looking and seeing, is this image about to be visible? It changes data source set, it copies this and puts it into source set. And then the browser wakes up and says, I see an image with a source set, I need to make a choice. And it does everything it would have done, it just does it only if they scroll. So we've used this lazy loading for a long time. That's another way to save a lot of downloading for things. I'll tell you, there is native support for this now. So again, if you go out to Can I Use, you'll see it's not everywhere yet. And I don't feel like polyfilling for our site. So for now, I still use lazy sizes. Either one of them is a huge improvement over downloading everything that people may never look at. If they're on a slow connection, if you scroll down super fast, you might see for an instant where the space is there, but the image isn't, right? While it's downloading the image. Life is trade-offs, right? If you're on a super slow connection, your first paint's going to be so much better not downloading these other 75 images that's a good trade-off for me. But that's just something you'll want to consider. The next one I call deferred loading. So the idea with deferred loading is I want to, instead of doing it lazy loading as you scroll, I just want to do it later in the page process. So the idea for this one, we use a lot of third-party stuff on websites. I have ones that are beacons or analytics or some of the stuff that has to happen in the background but doesn't affect how it paints. I would like to say move those to be later in processing. So I'll warn you, this is my own code that I created, and I'll show you another option here in a bit. And you can look, here's my JavaScript. Again, you'll have access to this code, but I patterned it after lazy sizes. So I've got this JavaScript, this third-party JavaScript. It doesn't have any impact on rendering, so it's a tracking or whatever it happens to be. Every vendor I work with says, you know, we're not going to make your site be slow. Well, script sources, these things make your page wait. If that thing is slow, it will wait and the page won't paint. And I'll show you an example of that in a minute. That's data deferred, so I do the same trick as lazy sizes. I made up my own attribute name, data deferred source. Here's the JavaScript. And then I wait until the page onload fires. So when the onload fires, it calls my method. And this method then just looks for every place it sees data deferred source, and it just copies from that into source. And again, that's when the JavaScript will fire. So I get my primary CSS and JavaScript to all run, my image is downloaded, the onload fires, and then I do all the stuff that's not part of the rendering. So again, it's a snappier paint and makes the other stuff wait. Okay. And again, the trade-off for that is it's possible the user might click and leave the page before some of that runs. It's possible, right? It's part of the considerations for what's more important to you. I really emphasize getting it to paint quickly. When we talk about loading resources, so I told you JavaScript is a blocking. It blocks rendering, so I'm going to show you an example of what that will do. So here's the typical naive. I've got 3 JavaScript files and some content. We're going to go back into Fiddler. Again, this is why I'm using Fiddler, because I can make stuff be intentionally slow. I wonder if I have my rules in here yet, now that I say that. I do not. So I'm going to request the page again. So you'll get to see a little more of this than I normally would do. But this is how you do it. So here are the 3 JavaScript files. I can just drag them over to Fiddler's autoresponder. And I'm going to make each one of those be intentionally slow. In other words, despite what the vendor says, they might have stuff that makes their download slow. So I'm just going to make the A, B, this is milliseconds, so 4 seconds. I'll do the same thing here. I'm going to make this 2 seconds. So I'm just going to change up and act like these things are slow because I want to show you what things do. This is one of the best things about Fiddler. I can individually make things be slow. So Fiddler's saying, when I see these requests, we'll make it slow. I want to show you what that will do to the customer. So if I go pull up that page again, I got to hit Control F5 here, sorry. Make sure that's actually running. Enable rules. Yep. So if you notice now it's slow, you can see the browser's waiting for those files, and what's happening, the customer sees nothing. It's a completely blank page. The JavaScript finally runs, and then you see the content. If those things are actually not needed for the paint JavaScript, so I would use the deferred method I just showed you because that's better than this, but if you can't use that or don't want to, you can use this JavaScript. Mine supports more than JavaScript too. That's the other reason I do it. It works for images and stuff. So I'm going to save this. What async says is, browser, this stuff does not affect rendering. So let the page render, do this in the background, and whenever they happen to finish, then execute them. You can see, I see the content right away, but you notice something interesting. 2 fired first because that one was slowed down less. So now the order of the JavaScript doesn't matter. So when I talk with vendors, they say, just use async. It will never impact you. It's not really true. Once it's done downloading, it will still execute. So while it's executing, it's going to still slow me down. I tend to like to use what's called defer. That's why I use my custom technique, because it does it a lot later, guaranteed. But what defer says is, I want you to also not block rendering, but wait until slightly later in the page lifecycle and make sure they fire in the right order. So if I kick that off again, you see the content right away, which is great. You're still clocking, but now it'll do 1, 2, 3. So it's just cool. Now you've got options for doing your JavaScript downloading in ways that don't block what else is going on. Another thing browsers have added is what's called resource hints. So these are things I can tell the browser to do ahead of time. So if we look at one of these, so I've got some JavaScript down here that I'm going to pull from Microsoft CDN. Again, I don't do that in production. I pull from my own, but you get the idea. It knows I want to pull something from another domain name. They've added this thing called pre-connect. So right away, I can tell the browser, I know that you're going to need to connect to this later, ajax.microsoft.com, but you're not going to find that out until you parse. And this is a simple page, but on a big page, it won't know that till later. Pre-connect says right away, go start making the connection. Get the handshake done, get the HTTPS done. So by the time you finally do get down here, now it can just start downloading the file. And there have been sites that this has made large differences for because the parsing is slow. So pre-connect is a good one to use. People abuse it. So I'm not saying to go pre-connect to absolutely everything you use, but a few primary hosts that you need to connect to, like my CDN, you can look at doing pre-connect. I'm showing it to you as a meta tag because I want to give it to you in the demo code. For real, in real life, I would make that be an HTTP response header. So that's something I would configure at the server level so that as soon as the browser starts to get the response headers, it'll say, I haven't even got all the HTML yet. I know I can go out and pre-connect to ajaxmicrosoft.com. So use it sparingly, test and make sure it helps make your site faster. But those are some cool new things that are built in. Prefetch is another one that if you come to your home page and you're pretty sure they're going to go to a certain page next, you can actually put in the prefetch. So what prefetch says is finish doing the page you're on, but start to download that other page in the background. That way, if they do click that link, it'll be already fetched, hopefully. If I don't have a site like that, I don't have a site that I know where you're going to go next, I could be hurting you by wasting some of your phone data plan on pages you never go to. So I don't do that, but if you have a very specific things, you might want to do that. A couple miscellaneous things. I focus on the critical rendering path. So all the techniques I've talked about, I really emphasize showing the page to people fast, and I'm willing to defer things to get that. The other thing to be aware of is URLs are case sensitive. So browsers care. So I'm going to show you what that would look like. So you can see I've got the same exact image here, but this is capital F, capital B. The second one is all lowercase, and or I'm sorry, capital F, and this is all lowercase. The browser treats those as 3 separate JPEGs. So even though I think I'm referencing the same thing, if I were to go pull that up in the browser and go back, I'm going to take image bloat off, sorry, it'll look prettier. That again. And this is still true for all the modern browsers. Even though it's the exact same image, it downloaded it 3 times. So what does this tell you? We have different developers. I like camel casing, so I would do capital F, capital B. Other people like all lowercase. So I did all the caching, all the work we talked about earlier. I minimized it, everything is sitting right there in your cache, but the next developer references it with a different casing on the URL, and all that goes out the window, and they have to come back and get the image anyways. So we just made the rule, all of our resources are lowercase. Makes it simple for us to know, and we don't make mistakes like that because our caching strategy if we do. I'll mention font subsetting. I was working on a site and they said, put this font on the site, and the font was 2 meg. And I said, that's a huge font. And I looked at it, and the problem was it had lots of different languages. A lot of Asian languages have very big character sets. So I took it to, I think, Font Squirrel and said, I'm a US site only, strip out everything but English and this typeset, and it was 28K. So from 2 meg to 28K. So if your fonts are relatively large, look into font subsetting and getting just what you need. The other thing, TLS 1.3 just came out. It's a lot better security. It's also good for performance. So if you're familiar with TLS, it's what HTTPS uses. Traditionally, it's a back and forth sort of handshake. It takes 2 back and forths, so 2 times your round trip just to set up an HTTPS connection. TLS 1.3 cut that down to just 1 back and forth. So we lit this up on our CDN and we checked the next day 20% faster just by setting a setting saying TLS 1.3. It's not available yet in Azure. That's why I'm not using it in my sample on Azure websites. But we did it for our CDN, it was 20% faster. Then we did it on our core homepage. It was also 20% faster. It's not very often you can click one thing and get better security and a lot faster, and it's because of how they do their connections. We still support 1.2, so if you have to fall back for older devices, but that's actually a good performance win. I talked about HTTP 2 before. I have a whole hour talk on this. I'm not going to do that here. The main innovation was this fully multiplexed on a single connection. So like I said, the olden days, if you were going to my CDN for 50 different things, it can only do 6 at a time. And each one of those has to establish a connection. In HTTP 2, it just makes one connection and it multiplexes all the responses across one connection. So you don't have to set up all those separate connections. So it's just a lot faster. So these are the things I used to teach people to do intentionally to work around the fact that you needed 6 connections and requests were expensive. So we used to bundle our JavaScript and CSS files all together. HTTP 2, I've seen a lot of people talk about this and argue it. They're not saying go back to 15 separate JavaScript files, but somewhere in between. A good combination of keep the files that are used together as a bundle maybe. If you've seen CSS sprites, used to take a lot of little images and shove them into one image and then use CSS to pick the right one. That's what a sprite is. Also not really useful anymore because the high level is that each request is not as expensive. So doing individual small requests for images is not a penalty like it used to be. So again, test all of this for yourself. But these are all things that I would teach people to do before that you probably don't want to do anymore if you're using HTTP2. I want to quickly show you a couple tools. These are things that are good for measuring your site. One is Google Page Speed. I'm going to show you instead the Lighthouse. So you can pull up your web page and right in DevTools, if I hit F12, there's a thing called Lighthouse. This is a lot of best practices built into DevTools. So I'm going to say I want to check out mobile performance for, this is the before version of the site. It's going to go look at all the best practices and it's going to give me a score and it's going to tell me things I could fix. So if you're new to performance, this is really handy. It's going to go over the stuff we talked about today, but it has a lot of links to where you can learn more. So hopefully this will finish somewhat quickly. But it's going out and scoring everything about that before. And this is the other metric that I use internally. I report this. So I scored a 36 out of 100. These are some of the metrics we saw before. I can drill into and see exactly what contributed to that score. Like, you know, largest contentful paint is 25% of the measurement. I was at almost 9 seconds for that. So I scored nothing. And it kind of breaks out. So that's cool. But what's cool is it tells me things I should fix, like do your image sizing. We already knew that. Use HTTP2. Don't block on JavaScript. So all the things we just talked about, if you're not familiar with this stuff, the cool thing is you can come out here and they have links to where you can learn more details. So let me clear this. I'm going to go look at the after version, cross my fingers. I'm going to do the mobile again. Desktops are usually pretty close to each other, but on mobile, they're simulating a slower connection. So your speed difference and your scores will be a lot different. So come on. Oh, it was 100 last time I ran it. That stinks. But I went from 36 to 97. So again, it's a number. And there are some sites that it's just showing that I am doing a lot of the best practices. It still tells me I could do take out some unused CSS. I didn't really get into that here today, but it tells me things I'm doing well. And so it's just a cool built-in thing that you can use. So again, before and after changes, I like to run that just to show improvements. And I actually use that for my performance reviews for work too. I say my goal, I'm here, I'm going to get us to here by the end of the year. That's something that then I can funnel my performance work into. Page speed is the same as Lighthouse, but it's also using the Chrome RUM information. So if you go out to that URL, you put in your URL, it'll do all the Lighthouse stuff, but it will also look at your RUM data that Chrome collected for you for free and tell you lab versus field. Like here's your Lighthouse score, but actual people on actual Chrome devices, this is what they think you should do. Couple quick resources. So I am a Pluralsight author. I do have a course on web performance, like a couple hours. I have a web developer's guide to images that goes into how do you compress. It shows you the tools, lets you do the slider. It talks about details about how you actually implement responsive images and such. Most recent one is debugging your website with Fiddler and Chrome dev tools. And also I have a very advanced one on just Fiddler Classic if you're interested in that. That's my Twitter. That's my blog and email, and the link there is where you can get the slides and the code. Again, it'll be the PowerPoint and then a before and after zip files. And then I have time if people want to go through any specific questions. So I don't know if there's anything out there yet.
There are no questions in the chat, but does anybody have any questions?
By the way, that's my biggest fear when I do virtual, that I just did the whole talk and my Ethernet connection was gone and none of you have been listening for, that's like the college nightmare that you missed a test. That's my, you know. If there aren't any in there now, you can also unmute and ask or whatever you want to do if you have specific questions. Otherwise, follow up with me after when you look at the code. If you have any questions, let me know. And like I said, if you want to see your actual site, if you show up to, again, it's that.us. And I try to do it, it's every 15th of each month is that.us. And if I'm available, I do a review where for the hour, bring me your URL. If we can get to it from the internet, I'll use these tools against your site and tell you specifically, like, you need to compress your JPEGs or you need compression or whatever, and that's all free. So if you're interested in that, I've got nothing to sell you. It's just a community thing.
If you have any questions, thank you so much, Robert. That was a great
Yeah,
talk.
you're welcome. Thank you.
Be sure to check out that online on 15th, get your own website up to speed. And once again, make sure to be a lookout for DevUp. If you want to speak at DevUp, call for business about next week. And next month will be Kevin Grossekloss talking about different tools that we use in everyday development. Once again, thank you so much, Robert. And I'll post
you're welcome.
His link to the slides and the recording on Meetup and LinkedIn tomorrow-ish. Well,
okay.
Everyone have a good night.
All right. Thank you.
Thank you.
See ya.